Okay. I'm fashionably late. By 3 minutes! Oh no! I've not set anything up yet, so let me just figure stuff out. Apparently, I am now a Twitch affiliate, which means I can run ads. Yay! But I have not set it up yet or anything, so probably not going to do that now. Let's see. No, that is not what I wanted. Right. Let me get a tweet out that I'm actually live. I haven't really, like I said, completely not prepared, like always. Okay, tweet us out. I should also start my coding PC. That would be helpful. Okay, let's close all of these tabs. Ko-fi, right. I wanted to attach that. So let's do that now. Okay, I'll be starting in a second. Just have to log into the other machine. Hi, Kakalak Joe. I was so late, I didn't even boot up my machine yet. Also, have not set up any ad schedules or schedules ad or anything like that. So, got into the affiliate program and then never set anything up for it yet. I'm still struggling. It's so much to do. So much to do that I don't want to do, but have to do. First ad, yay! I never thought I would be happy about ads, but here we are. Okay, let's see. I can show all of this. Is this set up right? Yes. Okay. So let me switch over to this machine. There we go. That's more like it. Right. Okay, so I'll continue with coding shortly. I recently had to play around with some of the settings for my code vault, because I want to prepare to make it public, right? Well, public to Ko-fi subscribers, supporters, right? So the assembler code base will be made available to supporters, maybe also to subscribers on Twitch. I kind of have to see how that will work. I have not figured it out yet. But that means I have to kind of set up organizations and all this kind of stuff and move some repositories around, and then yeah, we'll see. I also have to add a few more repositories. There's a lot of code repositories from my YouTube videos, right? So every YouTube video that I made out that had some code in it has a repository as well with the code that I showed in the video. I have to add that in here, which I haven't yet. There's only the assembler there. Then my own kind of helper libraries for C projects, right? If you want to do that. Yeah. Anyways, let's open this up. Why is it marked as changes? What did I change? Did I fiddle around with this after the stream? I don't think I did. Right, that is some old stuff. No. You know what? Close all other tabs. How about that? Maybe I should just check in Git what I've changed. Wait, why is this not working? Right, because you're connected to the wrong machine. Ah, there we go. Okay. So git status. Apparently I did change a few things. Let's see. Oh, right. Yeah, that's fine. So all I did after the stream was like, I added this calculate value thing to see how I would walk an expression tree to figure out the value that needs to be calculated, right? So if you were there in the last stream, you remember I'm able to parse expression trees now. So for stuff like this, with operator precedence, so it works. So 2 times 3 would be done first, right? And then 1 plus whatever the result of this is plus 4 would be done after that. And yeah, so parsing this would give me like an expression tree, and then I made just a little test method, function. There's some terminology that we'll never get rid of coming from C# after all these years, you know. Functions. We're dealing with functions, no methods. We resign from the Methodist Church, right? So I had this calculate value, which basically just walks the expression tree and just returns the value, or if it is an operation, then tries to walk to the left and the right side of the expression, and then does the calculation and returns that value from that, right? So this is basically just recursively walking the tree. And then I had a little output, I think. So if we do build run, you can see expression value. And if we look at the very first, so this would be this expression right here, right? This is 11. This will come to 14, and this to 5. Okay, and then we have 502, and then 0 for some reason, which is interesting. Oh, because this one. Yeah, so this is also part of an expression, right? It's just one number, so that's why it returns 0 here. And yeah, yeah. And then those are the hex values. But anyway, that's not part of the real assembler. That was just a test. Okay. Now, the way this algorithm works right now is basically producing a left associative things, right? So what I mean by that is everything is associated to the left value, right? So you start with 1, and then it checks the right value, right? So whatever you do here will be then added to the left, right? Similar 2 times 3, right? Let's do it this way. Everything will be added to the left. So meaning you have a 2 times 3, you do that first, and then you have the new left side of this plus 3, right? So it's all like shifted to the left. There's a few right associative operators. For example, what if I have plus minus 3, right? So this minus is not a new binary operator. Well, it is a unary operator, right? But this is right associative, meaning this minus belongs to this 3 on the right side. So I kind of have to figure out how to do that. So that is one thing. And then the other thing, which I have not thought about too much and really should have, and I might have to do it today and maybe do some drawings on the iPad or something just to wrap my head around this, is basically what if we have something like this, right? Let's do it this way. So you want this to happen first. Let's do it times 2 again. So basically, I want to handle braces, right? And we have to handle situations like, okay, what if we have like empty braces there? What's happening then? This is valid as well, right? It's just braces around the number. Like this should be perfectly fine. This, however, probably not fine. That is kind of a syntax error, right? Or right after this, some braces here. Then what if we forget to close the braces, right? That is also a syntax error. So yeah, kind of basically have to figure out how to parse. Sorry, I'm saying braces. Parentheses, right? And then another thing that's left to be doing is like, okay, what if you have variable names, right? Symbol names, because I want to be able to specify constants in my assembler, right? For example, you want to say const, I don't know, what's a good address? VRAM, right? So the start of VRAM is at, I don't know, this specific address right here, right? So, and every time someone types VRAM, it should resolve to this. So maybe what you want to do is you want to add something to the start of VRAM with a specific offset of, I don't know, 33 or whatever, right? Or 150 bytes, right? Something like this. This is valid, right? But now if you have a typo, let's say XRAM plus 150, right? Then this symbol cannot be resolved. So yeah, so what do we do then? That is a syntax error. Another syntax error would be if you have a register or a keyword or whatever and you add a number to that. That is a no-no in assembly, right? So at least in my assembler, I should say. Because the plus does not resolve into an add instruction for the Game Boy, right? This is purely for compile time. So any of these expressions here with plus, minus, or whatever, or and, or they're all resolved during. I don't want to say compile time because this is not a compiler, right? But during the creation of the during parsing, basically, right? So that will be interesting to do as well. And then another thing I wanted to tackle. So those are like the to-dos, right? Think of them as the to-dos. I should have put them in the to-do list here, but eventually I want to have it all here as issues, like issues trackers, so I can actually, track everything within this website. Just haven't done it yet. It all just takes time, dude. Plus, I have so many other things going on at the moment. I've maybe been tackling a bit too much. I don't know. But okay. So, right. And this is just parsing for the operands, right? So we don't have anything like, okay, we have instructions keywords like LD, right? Then we can have operands, comma, other operands, right? We don't do that yet. We also could have a label here. I don't know, foo, right? Like this. So basically, I still have to implement the whole parsing of the line. But I want to focus on expressions first because that is like the smallest unit I can do. So, but another thing to do is here in the node, right? At the moment, for test reasons, I just attached a full token to the node, which is a bit heavy, right? For example, every token has the line number attached to it, which, doesn't make much sense for the node because everything is done on a line-by-line basis. So they all have the same line, essentially, right? So we can potentially remove this somehow. I would still leave that information on the tokens, but on the nodes, it doesn't make much sense. Instead, what we could have is like one parent that has the line information on it. Now, the things that we do need is column and position, for sure, right? Do we need the length? Probably not, right? So we don't need this in the nodes either. Really, the only thing we need is values, right? So numbers, strings, or keywords. So what I'm thinking is, and token type might be too heavy-handed as well. So what I'm thinking is maybe I can make more specialized nodes, right? That makes the tree a bit more complicated, but at least it carries less information around. That means I have to reintroduce the node type, but that's okay. I mean, I really just did this for simplicity, right? To test things out while I was trying to figure stuff out. So maybe I'll leave this now in until I kind of have all these cases done. And then I can think about of making the nodes smaller. Because then I also have to think about how I design the whole, tree structure for a whole line of code, basically a whole statement. Yeah. I'm wondering, right, so unary plus and minus. Oh, there you have it, the associativity, right? So you see right to left, and then left to right. Okay, there's function call in here, but I don't see any parentheses, like any braces like that. Where is the C standard? Interesting. Sorry, I'm just looking in the C standard to see if there's anything else. A parenthesized expression is a primary expression. Its type and value are identical to those of the unparenthesized expressions. Okay. So that essentially means that whenever an open parenthesis is found, the contents within are being treated as a primary expression. But how would you do this in the tree, right? So this would be a node of this, right? The left side, sorry, I should have made it one of these. So that would be a node of star. And I did not turn off my alarms again. Classic. Okay, I'll leave alarm 12 and then a 2. Okay, so again, this tree, we would have a node of multiply right here, right? And the left side would be a 2. Actually, let's look at this case without parentheses first, right? So this would start out with a node of plus. The left side of that node would be a new node of multiply, right? That left side would be 2, the right side would be 3. And here the right side would be 1. Let's quickly verify that. All right, let's just plug that in here. Build, run, debug. Right, and I think just... Oh, no, I didn't have the... Oh, no. Change the working directory. Always forget that. Okay, and then jump in. Program area, parse source file, parse express. No, actually, don't need to go into parse expression. I can just go here. There we go. So now our expression, let's see. There we go. It's a token of type plus, right? So we have a node plus. The left side of it is a node multiply, and the left side is a decimal of 2, and the right is a decimal of 3. Right, exactly as I said. And then the right one is a decimal of 1. Okay. And now we have the case with parentheses, right? So essentially have to change the order around. We have to start with the multiply. And then the right node would be another node that is plus with a left of 3 and a right of 1. And let's say it was the other way around, right? Then we still need to start with a multiply, but then the left is this one, and the right side becomes 2. Okay, so in the normal way, without parentheses, right? Let's go down here. We're parsing a node, we're seeing a 2, right? So this left is a decimal of 2. We go to parse binary operator, which has a max precedence, right? And we just wait, does this advance the... Okay, this advances the Lexa. Okay, I got confused there for a second. Sorry. So we go in here, and then we encounter a binary operator, right? Which the precedence is lower than uint max. Now, a lower precedence value means it is higher precedence, right? You have to think of this precedence value as the order of operations, right? So, for example, 0 is the highest precedence because it is first in the list, right? And precedence of 1 is, you know, lower precedence than this because it is second in the list. So it can be a bit confusing that the numbers are the other way around, but I mean, you could just change them up however you want, doesn't matter. But that's just how it is now. So that's why we give it a uint max, because that is like, you know, 32 bits fully like FFFFF, right, in hex. So the highest precedence, sorry, the lowest possible precedence, basically. And so we have 3, which is a lower precedence, which means what does that mean? The new precedence I don't like how I made this way around. Okay, but essentially that means new precedence, right, for whatever the precedence this is. I think it is 2 at the moment or whatever. So this would be uint max, so it is not smaller or equal to 2. So we go in here and parse the new node. Now, this would create an operand node, right? And then we need to parse the right side of the expression. So we're just going to go in there. And this will go in here, right? So what we then see is a 3. Now, we parse the next binary operator, which has a lower precedence than this one. So we're stopping parsing, right? Because this is our new expression. So we just return the left side, which is 3. So which means we go in here, and left is the same as left, so we just return that. We go in here, and then that becomes our right side. Okay. And we then return the operator, which is our new left node. And then we continue from there. Cool. Okay, so this is our new left node. We then go into parse binary operator. We, again with view int max, we see the plus. So we're going to go in here, parse the operand, then this is the right one, right? So parse expression where we just return 1. Okay, so return this and return the operator with this as left and this as right, which becomes our new left. We then go in again, see that there's nothing there, right? So it's not a binary operator. So we just return left again, so this entire thing, and then we know we're done and we're going out of it. Cool. And now, how can we make this happen? Right. So we're starting with 2, which is our left side with the operator precedence. We have a multiply, cool, so this becomes the multiply operator. But then parse expression with multiply trying to get the right side, which now needs to become its whole own thing. So let's say, what if this has a higher precedence than this, right? Oh, we basically have to reset precedence here, right? Because in here we could say 2 times 1 plus 2, whatever, right? Or let's say 3 plus 1. Let's do it this way, right? We still want to sort by the right precedence here. So what we still want to do is have this first, right? or let's make the same example as there. So this scenario should still work. So basically, whenever a counter we abrase, we see this as a new basically have to reset precedence. Okay. That is fine. I can do that. And it's recursive anyways. But then this here then needs to switch back to the previous precedence, right? Okay, so reset precedence to U32 max and treat this as a whole new expression. But that is fine. So whatever is in here we don't care about, because if we have this, we pass in uint max in here. Okay, then we continue, right? And at some point, we encounter this, which goes into parse binary operator. We realize it is not a binary operator, so we just return left, which means we are done, right? So this whole expression is done. But then we need to figure out because we had this, we need to figure out if there is a closing statement now. And if this is not there, that is a syntax error, right? And we don't care about the precedence of this right now, because we just returned the new, like the right side, which returns the operator. And then we need to check again. Okay, cool. Cool. Okay. This is okay. I can do this. Unless I'm missing a very obvious case, but I think I got it. So it's down to parse node, which needs to be a bit more complicated, I think. Maybe instead of returning 0, I should have specific node types. And you could also have a flag in here of whether a node actually starts with a parentheses or not. That's actually not a bad idea. And I have not thought about how to report errors now. So at the moment, the left node just returns null. But it would be nice to carry a bit more information. Right? For example, you want to say unexpected token at this location, right? Because that is a syntax error. So you want to So I might have to reintroduce node types. Okay. Let's start with a statement struct. This will be the thing that describes the whole line, right? So this is a statement, right? Let's put this on the same line because that is actually allowed, right? This would be a statement. So basically a whole line. Why is this still running? And what information do we have in here? Well, we can carry the line number. And then I don't know yet. Right. We're just going to add some nodes. Okay, and then a node itself. Let's say we do have a node type again. Right. And our node type will be a value, an operator, or let's say node type empty, or node type invalid, right? So empty would be end of line or things like that. So we then can report errors such as, hey, we're missing operands, so and so, or whatever, right? Let's say, for example, empty would be if you have 6 plus, and then you're missing something here, right? That would result in 6 plus empty, right? So that would be an empty node. So we would have a node for plus with the left side as the value 6, and the right side would be empty. Well, that can be... Actually, empty is just 0, right? So, okay, let's just leave this at 0. So we don't need empty. That is 0. Okay. The whole node is just missing. Done. But invalid, right? So let's say we have 6 plus whatever we don't expect here. Let's say... I don't know. Geez. Let's say a bang, right? Do I need this? No, actually, I don't need this. Well, we could have token type invalid. Then the node is kind of invalid. And let's say we have 2 binary operators, right? So for example, let's say we have 6 plus plus, right? Then this becomes invalid. And then we want to stop anyways. Like, I don't want to continue parsing the expression because that doesn't make any sense, right? And I don't want to leave the node empty because, well, there is something there and we want to report what it is for like a proper error. So yeah, okay, node type invalid still makes sense. Let's leave that. Then we have, let's call this an immediate, right? Or we have an operator. So that still makes sense. Okay, node type, we have left and right. And then here, instead of token, what we're going to do is say... Well, we kind of want to know the column and byte position of the node, so we can report that in the error message, right? If we have invalid, we can say on this line, on column or position so-and-so, we have an invalid, like, token, whatever, right? don't think we need length. Come to think of it, where do we ever use length? Probably in Nexus C. Okay, I'm setting it. Okay, here on the error message. Token length might actually not be needed at all. So I can probably remove that from these in the future. To do, remove this. Right, because the only time when we actually care is like for error messages, but we know the length, we can calculate it inside the tokenizer because we know all these positions, so that is fine. But once we put it outside, we probably don't really need the length anymore. Even if we report syntax error for the nodes, we don't really need this because we don't need to print out the value necessarily. And if it is like one of these, like if it is a string value, it has a length given right here, right? So and if so, I know the byte position, right? So I can just print out a few characters of the line anyways, because I know where it is. So I can just print out a slice of whatever it is, if I really wanted to. So yeah, this I can potentially remove. Okay, cool. So let's continue here. Column and position, yep. Left, right, yep. Token now becomes a void value, right? So this is the value of the node. And I want to leave this a pointer because some nodes don't necessarily have a value, right? Like, for example, an operator doesn't need a value. Doesn't make any sense. I mean, I have that for the token as well, right? So this would be token type plus, and then it doesn't really need a value. But honestly, this might just be... This might just be overcomplicating the code. Okay, whatever. I can think of something else later on, but let's just leave this as a note. Let's call this expression node. Okay, then we have parse expression node, right, where we actually try to make sense of it. And this is where we have all the token types. So let's plug them all in there and see what we can do. Right, let's remove all of these. Right. And then, should have done this. Case, there you go. Okay, so token type end of file and new line just results in an empty node, right? That is fine. Okay. White space and comment cannot happen because we're already filtering them out in the lexer. So we never get these tokens at all. Then token type invalid. Right, so this skips to the next line. This is fine, but we want to return an invalid node, right? So I'm going to see how to do that in a second. Okay, so expression node means this is the first value of an expression, right, on the left side. And all the options are either, okay, we have a left side, even if it is just one value, right? So something like 1, right? It's just the 1. Or it could be a left side times a right side, right? Which again, parse expression node is always the start of this thing. Right could be, let's make this a plus. So a left can always be followed by a binary operand, right? Something like this. If we are on the left side and we are preceded by a plus or a minus, right? So plus left or minus left. Maybe I should just call this node. So then this becomes a urinary operator, right? could also have parentheses like this. We could start out with a parenthesis. It could be either empty or it could be node, right? Or it could be node plus something, or it could be minus node plus something, right? Or it could be minus node times something, right? Something like that. Okay, so I haven't thought about urinary operators yet, so but this is essentially these two cases right here, right? So plus and minus. We can figure out what to do with those later. Divide, multiply. If we have those cases, that is invalid, right? Because you cannot have those at the beginning of something. That just doesn't work. Right? Actually, let's do it this way. And return 0. Not implemented is a macro, by the way, that is basically like an assert. And if we have either of those, then we still want to skip to the next line. I can probably combine those cases. I just keep them separate in case I want, like, return different invalid nodes or something. I don't know yet, so, you know. But maybe we can combine these cases together. So open parentheses and close parentheses. Yeah, this is something we have to watch out for. Open square and close square. Now, this is a bit... So this is probably will function like open parentheses and close parentheses as well, except this is like a special thing. This is basically an indirection operator, right? So in assembly, you have this thing of like indirection, which means, let's go here, right? This star is indirection. I will change this star to be these brackets right here. I previously chose the star for indirection, but now I want to change it into these square brackets. But essentially what this means, so this is this value right here, right? Let's copy this line actually. So this is an address, right? And typically, if you do this, right? Actually, let's make this the other way around, just so I can explain this a bit easier. But essentially, this is now treated as an immediate value, right? And we want to load this value into the register A. So LD A and then the immediate value, right? If this was indirected like so and treated as an indirection, this basically means load the value of this address into A, right? So what this would be doing is, instead of using this as a value, it would treat this as an address, go to the address in memory and read the value from there, and then put that into the register A. So let's say somewhere on address FF40, we have the value 42, right? Then what essentially this translates to is load the value 42 into A, because that is what is stored on this address. Essentially like a pointer, right? A pointer is just an indirection. This is essentially a pointer in assembly. So, so these will become indirections. Indirection operator. And in the indirection, right, we can also have other parentheses or calculations of addresses, right? Like so, if you want to have a specific offset, right, this is all possible. If you wanted that. So we kind of have to treat this like open and close parentheses, essentially. Not sure how to do that yet, but we'll figure it out. Probably have a specific node. Yeah, I don't know yet. Okay, token type comma. Token type comma essentially means, let's make this a to-do. What? Do I have caps lock on? I do. What the hell? Right. Is it called unary? I never know, dude. Unary, yeah. Okay, you know what? I don't actually know what it means. Consisting of or involving a single element or component. Oh, it's an operator with just one component. English is not my first language, just so you know. Okay, cool. Okay, that's fine. That's why bitwise not is in there as well. That makes sense. Okay. Comma. How would I treat this in here? Comma is interesting. Comma has very low precedence in C. How does that work? So let's say we have all right, it sort of makes sense. So this essentially is just a separator, right? It separates one operand from another. So in our case, it would be separating one expression from another. But I don't know if I want to treat this as an expression. I'll probably do something with statements here. Yeah, because otherwise we're going to end up with like lots of different nodes. And I don't like that. We would essentially have something like So a node, which is the comma, right? And then we have left with expression 1, right? And then we have right would maybe be another comma, right? This is for the case if we have like something like A, comma, B, comma, C, right? So we have comma, left would be A. No, actually. I think it would be the other way around, wouldn't it? So right would be C and left would be another node with a comma, and that would have left as A and right as B. Yeah. So in cases like this down here where you have like lots of data, right? You would have like all these nodes, like a whole tree. Which to me is a bit bonkers, because like then you have to like walk the whole tree for just something that's basically just a sequence of data, right? So what I would rather have is probably just have a special node that is like in the statements or whatever. Well, actually, have a struct like operands, which is basically just a linked list, right, which points to the next item. And the next is another operand, right? And then the operand can have expression nodes, or it has one expression node as the root node for the expression itself. And these more or less would be contiguous in memory anyway, so it essentially boils down to just an array of like operands, right? Operands, 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 something like this. I think I would like that more like that. But I'm not sure I even need to handle this in the parse expression node, because if we have a comma, then, you know, I might have to. Because this could be seen as invalid then. Depends on where it ends up. Now, I probably would handle this outside of this. So this would never get a token that is actually this one. And if it does, it is treated as invalid. Okay. So these are binary, right? Okay, if we have a label in here that is invalid, right? these are okay, these are the nodes that are gonna be the value nodes. Token type directive is totally going to be invalid. Token type string, absolutely invalid. This is only used in special cases, I think. No, I might have to handle these. So parse expression might have to be a bit more complicated depending on what parse node returns. I think I need to treat most of them as invalid. Because this is going to just be in parse expression. And I filter out other cases for parse expression beforehand, right? So just by simple top-down parsing. So basically left to right. So the chain will essentially be parse labels, right? Parse instruction, and then parse operands of these instruction. Now, parse operands can either be a keyword, a string, yeah, keyword or string, or an expression, right? So you kind of filter out these cases already. Yeah. Okay, cool. Sorry, I have to get through this in my head. Right. So this is an expression node. I can just call it expression, to be honest. And this is just expression. So Alexa, we're looking at the current token. Yep, expression leaf. This will be 0. Okay, then most of them will actually be invalid. So token type, comma, will be invalid. Open and close square, I'm not sure yet. Token type string will be invalid. A keyword within an expression is definitely invalid. We need to filter that out beforehand as well. But identifiers are allowed. Essentially, the default case will just be the invalid, I think. Yeah, let's do it that way. Okay. So this will be null. And then we have, what did I do? So this is how I allocate a node. Sure. Expecting one of these. Right. We're allocating an expression leaf, right, like so, and if the result is not null, we set left and right to this, right? Then we have results column equals lexer current token dot column. Result position equals Alexa current token position. Expression type is an immediate. So result type equals expression type immediate. And result immediate equals Alexa current token number. And we advance the Alexa. Okay. Okay, and now the default case just becomes all the invalid ones, right? So if we add new tokens at some point or whatever, don't think that's gonna happen, but they would just be invalid. So what do we need to do for invalid tokens? Well, probably need to swallow them. No, we're skipping to the end of the line anyways. Actually, I'm not sure I like this. So if allocation fails here, it's not really allocation, right? It's an arena allocator, so it doesn't actually do any allocations on the heap. We already have like some reserved pages or whatever. It's essentially just treated as a stack, more or less. But if this fails, at the moment I'm pretending like there's something missing and just return 0. Which is fine, I guess. I don't think that ever happens anyways. Yeah, that's fine. Okay. Okay, so on default, we want to skip to the next line because we have an invalid token, right? And we probably want to do the same thing here, where we get a new token. We set this as invalid. That is fine. We want to know what invalid token this is, right? So, Okay, this doesn't make any sense. So what are we going to say? Let's say we have a string suddenly in there, right? So we have 1 plus string foo, right? So this is invalid. We will get to that point. We jump into default here, and we want to return an invalid expression tree, right? We're going to say, hey, invalid something. I think we just need a token type, right? I don't necessarily need to know the value of the token. Because if we have the beginning of a string, we know, okay, hey, there's a string in your expression which is invalid. Please don't do that, right? We're not going to print out the whole string. So yeah. Okay, so for invalid ones, and this essentially will just be a U32 as well, because that's what enums are, right? So we can just say token type T, token type. Right, it is token type T. Yeah, it is. had to make sure. So this is invalid token. So result token type equals Lexa current token type. Sweet. And then we just say return result, right? There we go. And if we, okay, so what about if we have a token type that's already invalid, right? So the Lexa already figures out that something is invalid. This token type will just be, so we have an expression type invalid and token type invalid, but we don't know what the invalid token type is. Well, it doesn't really matter because the Lexa has already put an error onto the list of errors to print out of what this invalid token is. So, you know, whatever. Okay, cool. So this is the default case. What can we see? There is a bit of stuff that's essentially the same, right? So what we can do is have expression result here and set it to 0, right? So, and then we can just say break right here. And in the end of the switch, what kind of is it? Token type. Let's do the full thing. We can just say return result. right? And then, hey, I'm doing all right. How are you? Having a good day? So these are essentially always the same, right? So, break. That's doing okay. I'm dealing with expressions still. I mean, got them working last time with the operator precedence, right? So now I'm trying to kind of streamline this a little bit and then dealing with parentheses and maybe urinary operators and all this kind of stuff. So we'll see. It's coming together. I kind of have a bit of a clearer mind of how to do things now, which is good. Yeah, it was a bit tough to figure out, but honestly, the code, like once you get it, it's not that hard to like think about. But yeah, it was tough to get to this stage, so that's for sure. Especially since it was the first time I was doing that. So let's put this down here for now. Right, so we're allocating a new expression right here, right? This is an expression type of immediate, and we assign the immediate thing, and then advance the Alexis. So that is cool, right? And then down here on the default, we do the same thing. We say it's an invalid one. We want to know what kind of token is invalid, but these, like, are exactly the same thing, right? So essentially what we can do is down here have a little if that says if result is not null, then you know, whatever you want to call it, top-down parser or whatever. Let me put it this way, I don't really care about these definitions. I just care that it works. Exactly. Okay, and with these I'll deal in a second. Let's just get stuff working that already was working. Okay, let's remove some of these. That was just me spilling out my thoughts. And call this parse expression leaf. Yes. Now in parse expression, okay, let's remove all of this. This will be expression T, right? It is kind of the minimum precedence we want to start with. Is my assembler... Don't worry, I got it. Is my assembler going to optimize code? Probably not. right? I don't think with an assembler you really want that, because like you want it to be straightforward, right? Essentially, you want to see exactly what it does at any given point. If you're starting to hide things and optimize things, I don't know. I don't know this if this would be the job for an assembler. If this was a programming language, sure. And in fact, I would love to write a Game Boy specific programming language at some point, because that would be lots of fun. Then we can talk about like optimizing code under the hood and stuff like that. Yes, then for sure. But in an assembler, nah. Okay, so parse expression. I have this up here, right? Actually, we can move this just slightly above this one. Then we have operator precedence. Okay. That's all right for now. No, I didn't. That was one of my goals that I wanted to do in the end, right? I'm just at the very beginning of what I want to do, essentially. I think after the assembler, I would like to try and write something for the Game Boy itself, right? And then I would probably want to try and write a disassembler for other Game Boy games. That could be really fun, and then see what some of the commercial games are doing by disassembling them and trying to figure that out. And another thing that would be really nice to write is an emulator as well for the Game Boy. That would be kind of fun. I know there's like thousands of emulators out there, right? But hey, what's one more? I want to learn. So no, not you. I should remember to disable voice activation for some devices when I stream. Okay. Okay, so this would be parse expression leaf now, right? And let's call this leaf. There we go. This would be expression. Next leaf. Let's call this binary leaf. Yeah, exactly. That's why the Game Boy, because it is easy. Like, it's a very straightforward instruction set, and as opposed to like with some other machines, it is, it is well defined in what kind of input capabilities it has and what kind of sound and graphics capabilities and stuff. So with all the other machines, all the other CPUs, I kind of would have to figure out a lot of other stuff first. Like, actually, the first assembler I tried to write was for the 6502, because of the Ben Ita videos, right? So I kind of got interested in that, but then I figured, well, I kind of have to build like a whole thing out of breadboards and stuff, and that is a bit too far of what I wanted to do. So yeah, I heard about Chip 8, but you know, I didn't want to do with virtual CPU because that's like, I mean, it's fine, but I kind of wanted to do something with real hardware just to get some of the intricacies there and like, and then expand from there. Okay. Parse expression, we call parse expression leaf, right? If leaf is not 0, then we want to do like this whole leafy thing right here, right? But then there's a few more things now, right? We can also return an invalid expression. So and leaf type is not expression type invalid. Right, because if it is invalid, we just return. That's all right. Okay, now, parse binary operator, if it calls parse expression here, it could also return an invalid node right here, right? But then we have an operator node with an invalid one attached to it. And we don't know essentially that that is the case, so we're just trying to parse again, right? So we're trying to parse whatever is after it. But since an invalid node basically skips to the end of the line, that will just resolve itself and then return. Okay. Nice. Let's just call this binary expression instead. Okay, parse binary operator with a specified precedence. That's fine. Yeah, I mean, we get to that probably in later streams, but essentially, just like this. It kind of looks like Z80 a little bit. But it has some special bit operations right here. Those are always prefixed with CB. I mean, that's what people usually say, that it resembles a Z80 and a mix of something else. I can't remember, but I don't exactly know because I haven't looked at the Z80 stuff, right? I'm just going to trust them. Whoever coded with Z80 and said it's kind of similar, the Game Boy is kind of similar, then sure. But yeah, it has this entire set of bit operations, which apparently the other ones don't have, I think, the Z80, but I'm not sure, so don't quote me on that. But yeah. I mean, it's not too bad of an instruction set, right? If it fits like in one page like this. Yeah, I know, right? It would be really cool to write a programming language for that. Yes. But I have no idea how to do it, so I'm gonna start with an assembler. Right. So here, once we have the left side, the only valid thing that can follow is a binary operator, right? If it isn't, we're just going to return. This should be expression. This should be expression as well. Right, 12 o'clock. So I'm going to take a coffee break soon. Should just be 5 minutes. But not now. Okay. Yeah, in the UK. 12 o'clock in the UK. Oh, you live in the Netherlands. I really like the Netherlands. Like, granted, I've only been to Amsterdam, but should probably visit some other places there as well. But every time I went, it was like really nice. And no, I did not go for like insane parties. I'm using the Sublime default ones. I don't know Vim key bindings. I'm not a Vim person at all. The only time I use it is when I push commits from the terminal for Git. That's it. And I just know to press I, to insert my little text, and how to get out of it with colon WQ. That's all my knowledge right there. I'm not doing anything else with it. I just can't deal with it. I don't know. I don't want to learn new key bindings and how that works. I mean, I barely know the Sublime key bindings, to be honest, but you know. Okay, so is token binary operator, that is something that is here, right? And that is plus, minus, divide, multiply, and or left shift, right shift, yeah, all this kind of stuff, which is good stuff. So we have that. Yeah, exactly. Also, my patience runs incredibly low these days with learning specific software. It's just yeah, this might be a sign of old age, honestly, but okay, if it is not a binary operator, then we just go out of here. And then whatever is calling parse expression, right, on the very top level, which probably is going to be the operands. So what it's trying to do then is try to read the next token and see if it is a comma or a new line, right? And if it is neither of those things, then that will report the error that there is an invalid token in there that we did not expect. that is not part of this code. So what I mean by that is, like, for example, think of 1 plus, I don't know, number sign, right? No, actually, sorry. Think of it as like so. So let's say we have forgotten the multiply sign, right? Operator, I mean, like this. So, no, it doesn't handle parentheses yet. This is what I'm gonna do, like, after my coffee break. But let's say we have this, right? So parse expression would essentially stop here because it would see this token and then see this is not a binary operator. So this is our finished expression, right? And then the code on top ahead would expect, okay, this is a valid operand now because we have finished the expression, right? So this is an expression operand. Now let's try and read the next one if there is one. And if there is a next one, so we have a next token and this is not a new line token, then we expect a comma, right? But because this is not a comma, we can then say, oh, expected a comma, a separator token, but found open parentheses instead, right? Okay, so this can all stay the same, except then we have parse expression leave, right? You know what? Get operator precedence. I kind of want to move that into the lexer as well. Yes, exactly. So I'll show you in a sec. So is token binary operator get binary operator precedence. You know what? Let's do U32 max for the default. Right, because it just takes a token, so it makes sense to put it like in the lexer where all the token stuff is at the moment. I realized I'm not making use of any of these, but that's okay. What is operand keyword? What? Oh, I did these. Yeah, whatever. This is get binary operator precedence, right? And then this is parse expression leave. And this should be expression. No, hang on. No. What did I do? This. Okay. This is parse expression leave. Oh no, I can't do that. This will fail now. Okay. Okay, when I come back from the coffee thing, this needs to be create operand node, right? Sorry. Create operator node instead of parse expression leave, because parse expression leave is like either the left or the right side, right? Okay, it's always the left side, right? And here we already know that we have a binary operator, and we just need to make a node out of that operator. So this should be a different function altogether instead of calling this one. And then here, parse expression with the new precedence. Yep, that is correct. Yeah. So basically, what you have to do for the operators here, right? We can give this expression a little flag whether it is starting with a new parentheses or not, right? Because we're always reading the left side first. So if we see this, we can already say, all right, put this in parentheses. And if it is, then we just have to reset the minimum precedence and continue with this. And basically stopping once we find an end one. But yeah, I'm going to do that after the coffee break. I'm going to grab some coffee now. It's probably going to take 5 minutes. Apparently, I'm able to run ads now, so I'm going to run a 3-minute ad break. Oh, God. But yeah, I'll see you in 5 minutes, approximately. Yeah, let's say 5 minutes. All right, see you in a bit. Okay. Apparently ads did not run. I don't understand this interface. It says preparing 3-minute ad, and then there's a countdown. Okay. I don't know how that works. So, well, if we have some ads popping up once the count, I'm waiting for the countdown to go down, and if there's some ads, I'm just gonna wait a bit longer. But I don't know how this works. It's my first day on the job. Hi, you wanna come here? All right, come here. You're being needy. All right, let's prepare you a pillow. You can be my rubber duck while coding, huh? Yes. Mate, it's coffee. You can't drink coffee. Okay, so the counter says 56 seconds. I'm curious what's gonna happen. It's gonna be a surprise for all of us. I hope that doesn't mean that then ads will run for 3 minutes. Well, I know for next time. I apologize. Three seconds. Did anything happen? I don't know what's happening. No ads. Well, isn't that jolly good? Hey! Oh, God. Well, that means we can just continue, right? That's excellent. This was a fail. I should probably read the manual at some point. Okay. You got nothing. You lose. Yeah. All right. So this should be okay. I have this little test code still here, so let me do that. That was just basically calculating the value as a kind of debug thing. So this expression now becomes this, right? Okay. So let's see if I can still build. No. Declaration of result hides previous result. Yeah, that is correct. Thank you. Thank you. Thank you, dear compiler. So, what is this? Token is not a member of expression. That is indeed correct. Expression type. Oh, right. Right, and I haven't done this yet. Okay, I cannot build yet. I was a bit too optimistic. Right. What we need is expression T, and then we say binary operator leave, right? And what we need is the Alexa. A bytecode math expression compiler. All right. For your own stack-based VM? Do you mean? Stack-based VMs are fun. Oh, hey, 2 spam messages at once. Oh, 3. Nice, nice. Okay, cool. The spammers came out of the woodwork. Nice. Thank you, Kakalaknjo. Nobody escapes the wrath of the Kakalaknjo. Okay, so here we just want to create a binary binary operator expression thingy, right? So let's just copy this essentially. Boop. Right. We know we have a result. Expression T like so, right? If the result is not null, we have an expression type of operator. Yeah. Imagine that. Ah, for Lua. I see. Nice. Dude, I just drank water. Why are you so interested in my breath? What's going on? You're right. I'm not eating anything, right? Okay, so I could have this. So we have either an invalid expression node, right? Or we have an immediate, or we have an operator. Now I could have the operator as different operator types. Or I could just assign the token type. I think that's probably the easiest instead of like overcrowding this expression type thing. We already have the ability to store a token type in there. Better than adding another. Yeah. Why not? Okay, if you hear any licking noises, my dog is just licking my hand at the moment. Dude, I showered. I don't know. Right, so this would be the current token type, right? So we're just gonna assign that. And basically do this. Right, and then we say Alexa advance because we want the next one in line. Right. Return result. Dude, would you stop licking my hand? Gee. I'm trying to type here. Oh dear Lord. She's cute though. I love that little thing. Thank you for stopping. Thank you. Okay. So we're creating the binary operator leaf like so. The only way this could fail is like if, again, allocation fails, right? And if it does, we just return null here. And we have this little assert here. Yeah, I'm using memory arenas. An arena allocator, essentially. If you want to see, it's right here. Essentially what you're having is like, you can specify the amount you want to reserve in memory, right? And the amount you want to have committed, how it should be aligned. And then you basically have virtual alloc here, which allocates based on page size, right? So it aligns all of the values that you pass into the closest page size, to the nearest page. I should say it that way. And yeah, you can then just basically request. You basically treat this like a stack, right? You can request a buffer of a specific size out of this. And whenever it crosses like the boundary of what you have committed, it just commits a little bit more. Usually a page worth, unless you request more than that. And then you also have the ability to like put stuff back, right? Or essentially rewind the buffer if you want to, so you can get the memory arena position and then rewind to that position, which is essentially what I'm doing here in the whoops, where is it? In the parser. Because like I don't need to hang on to all the nodes that are allocated after I'm done with them, right? So I'm just gonna remember the position of the memory arena where I'm currently at, whatever allocations happen here, and then just gonna rewind the buffer back to that position. To me, it just simplifies the code a little bit. At least I don't have to worry about like heap allocation and then freeing memory and all this kind of stuff. Yes, malloc, using malloc over and over is slow, exactly. And also you then have to worry about freeing all the time, which here you just, you know, because you can treat it like a stack essentially, you just have to rewind to the position that you were before you entered like a certain arena, right? And you can have multiple of these arenas as well. So the entire error handling, for example, in this has its separate arena. So if we go to error, yeah, there you go. It has its whole separate arena. At the moment, it just uses the default reserve and commit size, which is huge because I'm still developing this, right? So I didn't want to. Yeah, it's 4 kilobytes commit size and then 1 gigabyte reserved size. But I would eventually want to do is I want to have some tracking mechanics in here, which is, you know, you just look at the highest position that you ever allocated, so you can kind of get a feel of how much memory is being used for your application, and then I can like tweak the values. But because I'm developing stuff right now, I just, you know, made it huge. Yeah, it's huge, but you know, it's just reserved space, right? It's actually not allocating anything. It's just reserving the address ranges. So it doesn't actually consume anything, really, right? Yeah, sorry, you probably do understand if you're writing your own VMs. Just explaining this for other viewers as well, in case they're curious. But yeah, at the moment I just have 2 arenas, one for the error messages, and then the rest is just basically all on the same arena. But I might eventually split something out into separate arenas as well. For example, the entire symbol table might be a separate arena. I'm not quite sure yet. But it's fine because like most of the time where I do allocate, I just take an arena out, right? I just need to change whatever I pass in. So we'll see how this works out. Right, you ready to go to the bed now? Oh yeah, oh what a stretch. Okay. Let me put you there, milady. There you go. I'm glad to be of service. I swear this dog is so spoiled. As it should be, right? Right. Okay, so if this ever is null, let me think through this. So yeah, the only way this is failing is if the memory arena, so the virtual alloc is actually failing, right? And if this fails, I probably want to terminate the whole program anyways. But I kind of have this awkward pattern right now where whenever the allocation fails, I just return 0. I have not been handling it at all. So might want to change that at some point, but let's see. If this were to be 0, operator would be 0. And leave then would be 0. And once leave is 0, you pass in here, which triggers the assert. Yeah. I'm wondering, let's say this works. And then here, this would return 0, right? So we would end up with just 1. Yeah, I don't know. I have a to-do here, I think, somewhere. Oh, good God, I haven't cleaned this up in a while. What? Do you want to go out now? Okay, I have to let my dog out of the room again. Hang on. But oh, there you go. Think about error handling on arena allocation failures or general Windows API failures, right? So something I have to think about. Maybe I'll just make like an arena version that can just terminate when it fails. Like, you know, have something like terminate on fail, right? And then instead of returning 0 on new memory arena or whatever, or while getting the buffer, it would then call exit process. But I'm not sure. I have to think about it. Okay, hang on. I have to let my dog out of the room. Go. There you go. Bye. Right. Yeah, for now I just leave the assert there. But it's definitely something I have to handle at some point. I just don't worry right now about it. Yeah, you don't have exceptions. I mean, you do have an exception, and that is when your program crashes. That is an exception. Okay, so if expression type is expression type immediate, then we just return expression immediate, right? Otherwise, if expression, so this is just test code anyway, so I'm not gonna, right? Then we do this. And then what we want to do is this. Right. Otherwise, we're just going to return 0. Then we have expression token type. And that will do the right thing. Okay, so we go through here. No. We go through here, blah, 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 calculate value, right? And then we just print out the value that we calculated. Okay. At least C is fun. You can't over-engineer with classes and OOP. Yes. Yes, exactly. The whole reason why I'm doing C is because I got sick and tired of OOP throughout my software engineering career. Like, my main language of choice when I was working at companies was C sharp. Mostly in the backend area, but still, you know. And it's just, man, like professional C sharp code in the shops that I worked at, it's just mind boggling, right? You're just trying to figure out a simple thing of what a function is doing, and then you find yourself deep down 20 methods later, right? To figure out what actually is going on. Yeah, very over-engineered with OOP. Factory patterns everywhere. And you know you're in a batshit insane code base once you see factories of factories that create factories. I'm not kidding. It's just like, what is going on? So, but hey, that's what you're encouraged to write because it's professional, right? And yeah, I just got sick and tired of it, and I just wanted to see if I can write. See, get it? No. I wanted to see if I can write code more simpler and more straightforward to the point, right? And I kind of find beauty in stuff like this now. Like, it's just. I'm not saying this is like the most perfect code ever. Yeah, it's far from it. Good God. But it's just so easier to reason about, right? You just look at the function and you know what it's doing. It's like you don't have to. Yeah, okay, there might be some other functions in here, but you don't have to figure out like, okay, does this class inherit from this? Does it have behavior? Does it override some behavior from there? Or, all this kind of stuff. It's just. Anyways. It sounds like my dog doesn't agree with me. She keeps barking. Okay, so this should build. Ah, so close. So close, so close. Ah, it's a U64. Yes, 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 yes. Output, local variable not referenced. Really? I mean, this is just a warning, but like... Oh, this output. Yeah. I can say unused. There we go. Build run. Cool. Okay. 11, 14, and 5. I think that is correct, right? Wait. Where did you get these values from? Huh? If you write a large comment to explain a function, you're doing it wrong. Sort of, yeah. I mean, for some things, it's really important to like put into words like some of the edge cases or the reasoning behind it. So I'm not necessarily against long comments, but it can also go in the other extreme because in one of the companies I worked for, they had this mentality of like, code doesn't need documentation. Right? So you were discouraged from writing comments because the code should be self-explanatory. And then you look at the code and you have to drill down 20 methods deep to figure out what's going on in the debugger, right? And then it's like, yeah, no, this is not self-explanatory at all. And the naming didn't help either, because most of the functions were like named really awkwardly, or like sometimes very academic, and it's like, it doesn't really describe what you're doing. It describes a concept, but not actually what's happening. And yeah, so okay, I'm a slightly bit confused, because these expression values right here is stuff from a previous version of this file. Oh, I just went up all the way. Oh my god, yeah, I was looking at the I thought I cleared the screen before, but I didn't. Okay, no. So 7, right? This is still right. And then we have it this way, right? That should still work, right? There we go, 7. Okay, so at least I didn't break anything. Right, now let's do parentheses. Now is the time, now is the moment. Now we break everything. Okay, so I kind of thought about this before. So as I mentioned, once we go into parse expression leave and find parentheses like this and open parentheses, we kind of have to reset the precedence of whatever we're doing in this function right here, right? Because we're treating this as a completely separate new expression. Now we can go on and on and on and on and on with the same logic as before. Doesn't need any changes. But at some point, we're going to go in here and figure out that this token is not a binary operator, because it will be the close parentheses, right? If that is the close parentheses, we just return the left node, right? So we end up all the way here until we are at this stage right here. Now, the only thing we have to do here is see if the first leaf that we had was starting with a parentheses. And if it did, we basically just have to check the next token to see if it is closed. If it is not closed, then we ended up in a situation where we might have like something like 1 plus 1 times 3 plus 4, right? Something like this, let's say. So we have a beginning here, right? This is a valid expression, but this one, okay, let me make this clear by adding +2 here in the end. This one is not closed, right? So we would then have to attach an invalid node there to say, hey, we're missing the closing parentheses, right? I think. I have not thought about this yet. Whether I want to express it with nodes, or if I just want to have a flag. I'll think about it. What happens in cases of 1 plus 1? Well, so you read the left side first, right? You figure out that there's an open parentheses, but you continue reading this one as the expression leave, so the 1. You have a flag that this has opened, right? You go into here, into the parse binary operator. You would realize that this is not a binary operator, right? So your expression is closed. So you just return left, the one right here. Then we would go into this stage where we check right. I see. We cannot go out of here. We need to check it in here, right? Because it depends on what we return here. Because we do want to continue, because there might be binary operators after this. Good point. So check if the token is a binary operator before going into that code part. Yeah. I mean, so the thing is, if you have this, you also want to reset the min precedence back to what it was before, right? And We could, when doing parse expression leave, check for closing parentheses immediately as well. That's one way to do it, yeah. So in that way, we do not need to reset anything, right? And then once you then go here and you go into parse expression again, and if this has a closing, okay, check if it has a closing. If it has a closing parentheses, so let's say here, 4, right? Pause 4, it has a closing, so we shouldn't go into parse binary operator. No, see, this is the int literals are consumed here, right? In parse expression leave. I'm not sure about that. So basically, you mean like calling pass expression from within pass expression leaf, right? If there's a parenthesis. But I'm not sure I like that. Let me think about this. Yeah, I mean, I have no doubt that it works, but yeah, all right. Now, I just wanted to try and, separate nesting of these because that can get quite convoluted after a bit. So, to me, in my mind, expression leaf was like very concise, but like, yeah, it is the easiest way to do it. You're right. Because otherwise, I would have to like deal with like the state as I was trying, as I was saying before, where I have to reset the precedence and then this kind of stuff. And then this code becomes way more complicated. So, yeah, this is, you guys are right. Probably the cleaner way to do it because it involves less changes. Yeah, exactly. That's what I was going through in my head. Like, okay, how would I do this if I don't have this in parse expression leaf? Yeah. Convinced. Okay. Um, so basically, case. Where do I have these? I have these here. Bam. Doop, doop. Okay. Now, okay, close parentheses is probably going to be an invalid case in this instance because I'll check it after this one, right? So we have an open parentheses. And what we're gonna do is just call parse expression with the next token, which means Alexa advance. And here we have our expression, which is the result. With U32 max. Now, after we're done here, we go through this whole precedence thing and checking whether it's a binary operator or not, right? So after here, we basically want to make sure. Let me just check. So this would be a close parentheses. So we're gonna go out of here. So that is the current token. So the current token here would be essentially this or something else, right? We want to verify that this is this. So essentially, we're gonna be like if Alexa current token type is okay, so we pass the whole sub-expression, right, until we get to whatever the end might be. It might also be an invalid node right here. In which case we already advanced to the next line, right? So hang on. I'm trying to figure out failure cases now. So, and how to handle the close parentheses, essentially. So parse expression might just return 1, right? Or it could be an invalid node, right? So let's say we have an @ sign and pretend this is not what we expected, right? So this result would be an invalid node, in which case we already went to the next line. Maybe I should not do this, but I'm not sure yet. So it also becomes a bit more if we have something like right, and then you'd still have a valid node here, which just contains one invalid thing, right? And this invalid here would already skip to the next line, so I cannot verify the token whether it's closed or not. So that is the annoying part. What I would need is like So if this wasn't here, skip to the next line. It's just it is just skipping to the end of line token. Okay. So I could probably just yeah, don't worry. I appreciate suggestions, but I know it's hard to like just jump in, not knowing the code base, and be like, "Hey, you should do this." No, so in this case, right, the current token type would be new line. Because we encountered an invalid token. But that's like buried within this expression tree, right? Because this would be the first node, and this would be the right node of this one, right? The reason why I did this was just skipping to the next line because essentially I wanted to stop expression parsing once something is kind of wrong, right? You just want to report the first error and then just give up and go to the next line because that is the next valid thing to do. But I wonder if I should actually handle this in here at all, or it should happen further up. I'm not sure. But then expressions cannot be broken up into multiple lines in assembler, at least in this assembler. Which makes it a bit easier, right? Basically, it's just one line after the other. We just treat one line as a separate thing. Everything in here is just based on like one line. So if invalid wasn't there, I would not parse the next one. Right, so if this wasn't there, I mean, I'm already checking for invalid here, right? So in cases like I don't know. No, this is actually a valid token. I say this one, right? So this would be invalid, and it would not even try to parse any of these things. okay, what if it is like this? Right, so this is a whole new expression. We would parse this. This would be invalid. Right side becomes invalid. Which is okay. We return the operator. No, that can never be invalid. No, it might be invalid. No, it won't be, because we're not even going into the loop, right? So only the let's make it so, right? This would become invalid. It goes back to here, which is a valid thing. And then we try to read the next one, which is a binary operator. That's why I did the skip to the new line, because I didn't want to continue with this. But I'm wondering, does it matter? I mean, I'm just going to report multiple. I will get some kind of expression tree, right? And then once I walk the tree, if I encounter any of these invalid ones, that's the moment where I report the error, right? So really, yes, that's the shortest one, just a number. I'm just thinking like this skip to the next line doesn't make much sense. I should just consume that invalid token and continue and try and build a tree out of it. that way. No, so the idea with the skip was just to basically stop parsing the whole line, right? That was the idea behind it. So on the very first error that you encounter, like a token that you do not expect in this moment, like for that expression, I just wanted to give up, right? But then you kind of run into issues while doing this. So I think I might just try and build the tree anyways. Have some invalid tokens in there, and then whatever the parser when it actually walks the tree to like figure out what this expression is. Yeah, see, no, I didn't. I should specify. I just wanted to give up for that line. Right? I still want to report other errors further down in the lines. The only time I actually stop parsing altogether and terminate the program is if there is a UTF-8 sequence that is invalid. So let's say you have an UTF-8 character that is expecting 4 bytes, but you only supply 2, and then the other one is just like a new start of a sequence, then I'm terminating there because I'm like, oh, this file is corrupted. Like, stop it, right? But everything else, I just want to report all the errors line by line. Even if the output doesn't make really sense or anything like that, I want to... I don't want an assembler where this whole thing of like, oh, you fix one line of code and then you build again and then it reports the other line of code, right? Since everything is just line-based, I just wanted to print out all the errors for all the individual lines. But then, yeah, this situation is then kind of annoying because, as I said, when I like skip to the last line, in situations here, I cannot really distinguish if it is the actual end of the line and a close parenthesis is missing, or if this whole expression actually was an error, right? And I don't really want to have like a separate struct that can either be a valid value or an error or things like that, like a result type, because that just overcomplicates everything as well. So I might just really have an invalid node in here and then just try and continue. And if there's a comma in here, like, right, you have an invalid one, and this one is not a binary thingy, so it will actually just stop the whole thing, and then the top code, the calling code, will take over from there and just continue from there. So, yeah. And maybe you want to be like, okay, this is invalid, but you're also missing the parentheses. Maybe I could print out those 2 errors. Because as the code was before, like, it would just report this as invalid, and then we would fix the issue, but then you would have another error popping up saying, hey, the parentheses is missing. If I can print out both of them, maybe that's better. In which case, I really just need to consume that one token. Yeah. Okay, I'll try this. Just consume that token. And then here, I just need to make this check, right? For the close parentheses. Also, good question. Like, what? This will be reported as an invalid token. So if I do this now, 1 plus, and then only have a closing parentheses, this would end up as a node with plus, where the left is 1 and the right is invalid. What I could do what I could do is also have maybe a flag on the expression itself. To indicate whether it has an open parenthesis and a close parenthesis. I'm not sure if that would make sense right now, but that might not be a bad idea. So let's do this, right? And then you would have something like result parent, I don't know, open, right? You know it is open. You check for the current token type. I mean, whether if it is closed or not, and then you can say results para, I don't know, something like, sorry, or right. If it doesn't have that, you only have the open flag, and you know there was never a close. And then we can have token type close para. I never did a break here. Oh dear. So this would be for situations like 1 plus or just right? Or 1, right? So in this instance, you have a number, okay, fine. It would try to read this as a binary operator. It doesn't have one, so what it would do is this would be the expression, and then this is a leftover for whatever comes afterwards. Yeah, it really is harder to implement, right? I thought this would be easy as well. In my head, I was like, yeah, easy. Okay, I can deal with that. We could do a special case after having something valid to then figure out if there is a close para or not to set the right flags if we needed to. But okay, no, let's not get ahead. This would be... Okay, no. It's fine. Sorry. Okay, then on this case, this is essentially similar to this, right? So we just need to handle this case. So we have this. At the moment, this would be reported as an invalid token. And it would just continue ahead. What if I just report null? Right? So I do this. And then whatever calling code needs to deal with that, that is fine. But if we are like in here, okay, so this would report null. So right would be null. Operator right is null. We return the entire operator. We go to the next thing. Try to see if it is a binary operator. It is not, because we have not consumed it. We're just reporting null. Right, so we go out of here, return the entire leaf. The entire leaf is here, where we can then check for the closing parentheses, which is the current token. So it will set close, but we won't have an open flag. Oh, wait, no, we're not going in here. What am I talking about? Jesus. No, we are here. Shit. Just report null. Okay. So for instances where we only have a closing parentheses, I think reporting just null and pretending like this is the end is fine. Because it's just the expression node that is 0, right? Then the calling code or whatever will still continue and see that the token is actually not end of file and not end of line, and will just continue trying to parse, right? So this is really just to get out of this expression thing. So this is okay if I don't consume it, and then let the calling code handle whatever, saying like, oh, extra thingamajiggy, right? And then this one right here, where we set the result with a flag, I mean, we know that we have an open parentheses here. And if we reach okay, what in instances of okay, sorry. What if we have so we have an open parentheses, right? Like so, that is fine. Go in here, we do our whole expression thingy, we check for close para, we set the flags to open and close. This is fine. Okay, cool. What if, so if we open, but never close. Or what? Then we have an open thing. We do our whole expression, something is missing, so we return 0, right? So the right side would just be 0. We go in here, we check the next token. There is no close para, so we never set that flag, so it just has an open flag, but not a close flag. Now, if there is an open one, plus, and then no number, right? But we have a closed one. So it would go in here, it would go in here. It would see this. This would be reported as 0. We're not advancing. And then we're back here in this code where we check for the closing parentheses, which is there. But the expression tree, then when we later parse it, it will kind of fail because we have a binary operator where the right side is null. Invalid, right? Okay. And I think this will work with multiple ones as well. So what about 1 plus bogus, right? And close, and 1 plus bogus and not close. And what about... So any of these cases where we have a closing one, even if we have bogus closing, then it will just work because the calling code will be, okay, is this a binary expression? Sorry, a binary operand? It is not, so it will just fail. Sorry, return this as the expression, and then the calling code can handle this case. So basically, on a closing without an opening, we let the calling code handle that, right? Ah, but what about... Okay, there's another case I have to think about, but what about 1 plus... let's do it 1 times 1 plus... Right. Okay, so 1 plus 1 plus 1. Okay, I'll walk through all of these. let me just walk through this one, right? So we have an open parentheses. This is fine. We go in here. We report bogus at some point. We're just going to consume. We check for binary operator. We do not have a binary operator, so that means we are going to return, and we are done with this expression. We check for the end closing para, and the closing para is there. Fantastic. Cool. So we set the flags. On this one, we're just gonna do our thing. We check the next one. It's not what we're thinking it is, right? What if it is an open brace? Well, it doesn't really matter because it is not a closing brace, which means there is something wrong. But then I also probably shouldn't consume it. We're just going to say a closing brace is missing. Okay, so I have to be careful with the consume here. Careful! Right? Okay. What about this case? This, right? It's not one of these. So it will be empty because we're reporting null. Right, so this will remain empty. We check for the next one, which is a binary operator. All right, thanks for watching and helping out. Much appreciated. So here, this is not a... So we have a missing one. We go out, we do this again. This is not a binary operator. So we're just gonna finish this. We're back in here. We check for closing parentheses, which this is. And then we should consume it. Right, so we go out of that. And then we are in this instance right here. In which case we report this as the right side. We check on this. There's nothing there. So the parentheses is not closed. So this one would have an open flag but not a closed flag. Okay. We're getting somewhere. Okay, what about this case? Open parentheses, right? Okay, we go in here, parse expression, yada, yada, yada. Here, parse expression, yada, yada, yada. Cool. We return 1, right? We check for binary operator. It's not there, so we are going to just return this. So parse expression will just return this. Now we're back in here, which means we look for the close token, which is there, so we're going to consume it. Cool, so this is our sub expression. Now, our sub expression right here becomes the left-hand side of this. We go in here, we do this, right? We're closing it. It's not a binary operator, it is a closing parenthesis, so we're closing. Set the closing flag. We go in here. This becomes our left side. We go in here, do this. Yeah, that should work. Famous last words. almost 4 hours for the stream, so I'll probably need to wrap it up. But I want to get these parentheses working. That is... But I think I got it. So open parentheses, Lexa Advance, parse expression. Okay. Let's have two. Yeah. Okay. So here, open parentheses, and then, okay, so if the current token is a close parentheses, then we say result flags is this. Close. And because it is close, we want to advance. If it isn't closed, we just don't set the flag and don't advance. What? All right. Parse expression undefined. All right, yeah. Okay, now I do not have checks for the calling code, but let me... Okay, I don't necessarily like this. So let me think about what if I do report this as an invalid one, but don't consume. No, that doesn't make sense. I think this is okay. Famous last words. Okay, let me figure out how to deal with that in expression terms. So at the moment, the test code just calls parse expression because we can only have one expression per line. That will later change, obviously. I will have multiple expressions separated by a comma, but that will be, some other calling code that is handling the commas and stuff like that. So what we want is we're going to go into parse expression. While parse expression is not 0, right, it always returns something, except if it is an open parentheses, then it won't. So really, what I want well, I already have the token types here, right? So this will return a null. I rewind this, but what we can do is if Lexa current token type equals token type close parentheses, then write output string. Well, I should add this as a proper error, to be honest, but I will get messy now. Okay, let me add some proper error handling, and then I forgot the signature. The Lexa itself is holding on to the source file, I think. Yeah, okay, cool. So we can say add source file error, which we'll call add error. No, it's not a source file error. That's the problem, isn't it? Okay, I have to do it this way. Okay, add error. We have the Lexa file dot file name. We have the Lexa line. We have the Lexa column. No, we don't. No, we do. The Lexa column and the Lexa position, right? Because we have not consumed this token. And then we can say close paren without an open paren, right? It's obviously not the final error message. I just want to have something that prints out to the console. Okay, so that is that situation. And then here in calculate value, which is just debugging code as well, right? I have, if it's an immediate, if it is an operator, I'll do this. Let me just also add if expression type equals, no, you know, if we reach this code, then we just add an error, whatever. And what we want is, shoot. Source file t. Right, let's just do it this way. That will be file name. And then here we will be in file line. You know what, how would we just pass the lexer? Lexer t lexer, right? And then we can say lexer file name. Lexer line, lexer column, lexer position. Nope. Okay, the line will be wrong for now because I don't have. No, actually, the line will be okay. By pure stupidity. Dumb luck. But, okay, so this should probably be expression column and expression position. And then we can say invalid, no, unexpected token. And just because I'm lazy, I'm going to print the token type in hex. Expression token type. Right, and okay, what is the other situation? The other situation is that the parent expression here doesn't have a proper close, right? So if expression flags and expression flag open para expression flag let's call this So usually what happens is that we never have just the close para flag, right? Maybe I could do that. I actually might be able to add that into the expression as well. I just realized, but it just depends on like, so on every single number here, I should make another token check if there's like a close para, but I don't know. We'll see as I get along. But basically, missing close para, right? That is the only thing that can happen here. Also, I should add new lines. Okay. Oh, whoops. Right, it's not dot file name. It's pointer. Okay. Line is not member of Lexa, really. Fine, it's probably Lexa file line. What? Oh, right. Yeah. This needs to be Alexa. One more, apparently. Yep. Okay. Column is not a member of Alexa. Right. Never mind. Oh dear. I should have just used source error, but okay. Right, but here, if I have a close parentheses, I need to consume it now. Okay. Now, 1 plus 2 times 3, right? So 7, right? But now if we do this, right, then 9. Yeah. Actually, how about I just copy some of the... Of course I deleted them. Anyways, let's do some of these cases, right? So 1 plus 1 plus 1, right? That should be valid. And what if 5 plus 5 and a closing thingy? What if 5 plus closing? What if 5 closing? What if just closing, right? Same with open, just open, nothing else. Oh, I haven't thought about... Okay, whatever. So open 5, open 5 plus 5 without closing, right? And then... open 5 plus. That's not a good sign. That's not a good sign at all. What is happening? Oh dear. Every time. Expression is 0? And how? Oh, because left or right could be... Yeah, of course, of course, of course, of course, of course, of course. This is too much code for like just debugging purposes, because I essentially now do all the parsing, calling stuff with the error handling, which not really what I want to do, but okay. So on these, is valid expression, lexer, t lexer, right? Expression t expression is valid operator expression, right? Let's do it that way. And then we just need to make sure that left and right are actually not zeros. So if expression left is 0, we report an error. And if expression right is 0, we report an error. B32 false, B32 false, B32 true. Right, and what we're saying is whoa. That was the debugger still running. All right. Build run. Nope. That was not it. Really? No. Why? Oh, because I'm not calling it anywhere. Jesus Christ. Okay, we reached a point where my brain stops working. So, if is false, is valid expression, Lexe and expression, except we do not do this here. What we're going to do is we're going to do this here. It is an operator, right? And if it is none of these, let's just return 0, whatever. Nope. What did I miss now? Result is 0. Yes, that can happen. Absolutely. Absolutely right. And if it is 0, wait, why can it happen? Because of the open parentheses, right? Because there's nothing there. So really, shit. Oh no. Well, the flags are really just for error reporting in the end, right? That's the only reason. Because I do not want error handling in this thing where I built the tree, right? I want the error handling to happen later on when I validate that tree, or try to validate that tree. But then, yeah, I mean, you're kind of right, I suppose, because, like, there would only ever be one unclosed parentheses, right? Like, at the very end anyways. In which case... Have I been overthinking this? I mean, okay, hang on. That looks wrong. Oh, lordy lord. Yeah, and this is completely wrong. Because I'm setting the flag for the 1 and not for the plus. I really botched that up, didn't I? And here I was so confident that I got this. Oh no. Oh no. No. Ah. I mean, maybe I should just bite the bullet and do the error reporting in here, right? In parse expression leave, right? Instead of like pushing this further and further out. And then really the only thing I need to check is if there is a closing para, and if not, then just report the error as missing close para. Wait, no, why? Why would that be on the 1 though? Hang on, what? There's a whole bunch of stuff wrong. This doesn't report anything anymore. I've broken everything. That's not how I wanted to end the stream. I'm breaking everything. No! No. Operator. Multiply. Two times 3. Okay, no, so this is correct. So I might have just screwed something up in calculate value. Yeah, definitely. So what did I do wrong? Let's tackle that first before I think about the parentheses flags. Right. Yeah, that will do it. Right, actually. Then I need to do this. Whoops. Right. Right, you're still running. Okay, so at least that works. But then line 2. What? Right. Okay, let's look at the expression again for the next line. Okay, this is line 1. What? are you already saying line 2? Okay, whatever. Okay, so expression multiply the right side is an immediate of 3. Immediate of 3. Yes. The left side is then the operator plus, right? With flags set to 3. Huh. So why oh why is left and right empty? Because I'm an idiot. That's why. I am officially an idiot. Let that be known. Right, so while trying to be clever to set left and right always to 0, I shouldn't be doing that for this. So in my quest to reduce the code, I made it wrong. No shit. We also don't want to set these, right? So really, instead of breaking here, what I want to do is return the result. Right. Okay. There we go. We now have a 9, and we now have a 3. Huzzah! Okay, for some reason, here we have a 10. Okay, from now on, this is not to be trusted because, you know, I'm printing out the value regardless of whether it is right or wrong. But then if we look at the errors, we can now, oh my lord. Where do the errors begin? There we go. Well, this is not ideal, is it? Ah. I think I know what's happening here, because this is offset by 1. So it says line 6, but it is actually line 5. So I have to figure out what I screwed up there. And this is close paren without an open paren, yeah, which is correct. And then line 7 operation is missing right-hand side, which indeed it is. We have a close paren without an open paren on the same line here. That is correct. Line 8, close paren without an open paren, yep. Another spammer, yay. They're on a roll today. And then we have line 9. Wait, so line 5, line 6, line 7, yep. And then line 9, which is line 8, yes, close part. Okay, cool. And then line 12, which would be line 11. But I'm not reporting this one, right? Because it is. That's just the nature of my calling code at the moment. Thanks, Kakalakjo. So let's see what would happen. We have an open parentheses, right? Parse expression. It would call into open parentheses. Let's close all this. Parse expression leave. Right, we have an open parentheses. We advance, which would be new line. We're trying to read. New line returns 0. Right. We go to 0. Ah. Are the hector counts really? Nice. Okay, so, well, I'm kind of happy but not happy, right, with this. So the parentheses seem to work. I do need to make a bit more test cases for these. But then there is a lot of edge things of like how I'm doing the calling code and line reporting. Like, yeah, I don't know why that is wrong right now. Right. Yes, I do know why. So, line reporting is wrong because the token has already been read. It has already been consumed from the file. So the file line will automatically point to the next line because we already have a new line token. That's why. So this is just the nature of the design of what I did here with the Alexa and how the file reading works. So, okay, that makes sense. Even more of a reason to maybe report these errors as I'm parsing already and noticing some of these things. I just need to have a way to then dismiss the whole expression at once, essentially. So maybe just returning null for the expression. Or maybe just an invalid expression thing. You know, just returning one note saying, well, this is an invalid expression. Or essentially null. And then the error will already be added because I'm adding it down here. Right? Yeah, maybe that's a better design. And then I don't need to worry about these flags at all. Then I really can just report right here. And the result will just be invalid. And if I encounter an invalid one, I don't really care why it is invalid because the error will be added here. So in case of any other tokens, I could already just say, oh, well, this is something I do not expect, right? And I know this because I'm having invalid here. So I just call add error right here and add the right error, right, to the error list. And then later on, when I validate a tree to then get the right value that I need to put in the binary, I can just say, okay, you know, if you encounter something invalid, just stop and don't write anything. I don't know, maybe. But yeah, those flags are probably unnecessary. Okay, I kind of know how to clean this up, but I'm not sure I'm going to do it now because it's been almost 5 hours. GS. Oh, okay. And I have some other stuff to do today as well. So, I think I'm going to stop here. I know it's not really a satisfying ending. But I mean, it kind of works, right? So at least these two values were returned as expected, and this one. So parentheses kind of work, but the error handling doesn't really. And it can be done a lot nicer. So by removing the flags and stuff like that. So thank you, Wyoming, for pointing that out. By asking the questions, why do you need to set the flags anyways? Yeah. I was just kind of over-engineering it in my head. Trying to figure out where I should put the to-do so I know where to continue next time. Just maybe just make me better, right? And next time when I try to build, I'll just see this and know something's up. Okay. And maybe it's easier if I just remove these like test functions right here and just start sort of constructing the calling stuff anyways for the whole line, to parse the whole line. So have something that calls into, okay, if we have a label, call into the label code, but just leave them blank for now, right? So I'm just gonna do nothing. Yeah, maybe that's a good idea. Well, I still need nice error messages. Fine. I mean, I do have that. Do have that. Oh, this is for dictionaries, right? For error reporting. What figure out fashions assembly keywords from other symbols? I mean, oh, right, in the dictionary. Okay. Yeah, that's it. So for Ko-fi backers, I still have not properly managed to get my my Gitty instance publicly available for the source code of the GameBoy assembler, but I'm working on it. Right, I just have to figure out how to, split up access to different tiers and stuff. So I need to do that. But hopefully by next week I can have something properly running, and then share the source code, which at the moment is a mess. But hey, whatever. This annoys me that this is not properly done. I'll probably code a little bit later on, maybe tomorrow or something, but no promises. Anyways, yeah, this is where I'm going to leave it. Thanks for watching, and I'll see you guys next time. Hopefully. Where's my mouse? Oh no, my mouse lost battery. Fantastic. I cannot end the stream. What do I do? I have an emergency mouse. Woo! Otherwise, I'm just being trapped here and I have to code forever and ever. Okay. Right, okay. Thanks for watching. Bye.